Okay, sure.
Thanks.
So today's topic is about introduction to beginner's guide to the Kubernetes and how can we use the first API with Kubernetes. Okay. So any idea of anybody have worked with Kubernetes or have idea what is the Kubernetes is?
Uh, Hello, sorry.
Yeah.
Yes, it is a container management tool. We can say like
Okay.
a container management tool.
Okay. Okay. So let's go with the understanding what is Kubernetes. So basically, when you say container management, the actual thing is a container orchestration, right? So we have already know about Docker, right? Docker being the container runtime, and we can create a container using a Docker file, and maybe in our local we can use a Docker compose to do that. In AWS, we can push that particular image of Docker into the ECR or Elastic Container Repository. That's maybe can be configured as a private repository, and from there we can using the ECS container, that is their AWS container orchestration service, they can deploy one or more services and one or more container within that services. Now Kubernetes, but the ECS in AWS is basically a proprietary tool. It's not open source, but if you wanted to look for a container orchestration tool which will take care of starting, topping container and container lifecycle, in case of a crash it's going to be recreate or reschedule that particular and allocation of the container across the different node in our clusters. So that is in Kubernetes, and AWS and every cloud provider provide a managed Kubernetes services. So in case of AWS, it is known as EKS or Elastic Kubernetes Service. Now this open Kubernetes tool or orchestration tool has been developed by Google. And what it does, it's basically manage the container. What do you mean by management? That means it places the containers into different systems. Maybe it's a physical barebone server, it may be a virtual machine, it may be a cloud VM, or it may be a hybrid combination of different deployment environment. Okay. Okay. So why we generally see uptake of Kubernetes is that more or less people are creating smaller services for quicker prototyping and much more speed with agility giving business value. So there is a migration of creating large application to a group of application which take care of the individual minimal application need, right? So basically people are moving from monolith to microservices. And for microservices, how we can run them? We basically mostly people create containers using Docker or Rocket kind of container runtime that is there, and they create the container to more and more are increasing, right? And we can see in production environment there are hundreds of microservices, maybe some large scale we can see thousands of microservices and hundreds of containers to be right. So what is Kubernetes provide? It provides high availability. That means the services are available 99.9% or 999.999 availability, 99. So our services are not down. Scalability means it can scale both up as well as scale down depending on the demand that is there. Okay. Then you have disaster recovery, that is backup and restore. If your application gets shut down If, for example, your database servers which are running in a container, if they somehow get crashed, they can be restored. But this backup, snapshotting, etc., is that this is outside. You have to take care of it. Okay. So Kubernetes benefits are those. Now let's look into what are the different components the Kubernetes provide. So any kind of services or container running, it requires a physical or virtual machine. So in our boxes, what we have, the virtual machine is the Rancher desktop, and Rancher desktop runs on the WSL and the virtual VM in case of a hyperversion, in case of a Docker desktop, right? So that's the worker node where the actually one or many container runs. Now the worker node need to have few things. It need to have a container runtime. That means it need to have either Docker install or similar capability available. Now we normally what we do Docker run and we give which image to run. Now what is pod? Pod is basically an abstraction over that particular container. It is the most smallest unit in the Kubernetes cluster. Okay. So basically generally people do is they deploy one application into a pod. The pod is a logical box. Okay. And each of the pods gets their own IP addresses. But these IP addresses are not static, they are dynamic IP addresses. And Kubernetes also create a network. So one pod may be able to communicate with another pod. Okay. Now every time the pods are crashed or pods are recreated or new pod being created, they each get a dynamic private IP address. Now these dynamic private IP addresses are not good enough to access the particular service from outside. Okay. So in that case, what you need to do is we need to have another abstraction on top of pod, which is known as service. Service has a public permanent IP addresses. Those are doesn't get changed. Okay. And the pod lifecycle, that is the pod creation, stop, or reschedule, doesn't impact the services. They are independent of that. Now services can be internal services. That means, for example, you have two things. So you have like a MongoDB server. It is a service, but it is internal to the Kubernetes cluster network. It is not accessible from outside. But the service for the application API, which may be the public or external service, and the services is basically does this is act as a load balancer. Okay. But again, those IP addresses are private for services. So from accessing from outside, what you require is on top another abstraction is known as ingress. And ingress, you can put the ingress rules, like which port can be open or which kind of subset this particular service will be available. So it's like an ingress that receives the outside traffic, and then that is forward to the service that is internal or external, and then they are able to communicate. Now, what happens if your service's name get changed? Or in the case of a MongoDB, if your application server need to connect with that, it obviously every service node has a name, right? So you can use that particular name in your application configuration. So in case of FastAPI, it's application configuration where you can say, instead of saying any kind of IP addresses, we give the particular service name, right? Because the pods are basically having dynamic IP addresses. So static IP address is the service one. So we call them by the service name and the port number. Now, if the service name get changed, what I have to do? I have to again rebuild my code. I have to change the configuration, build a new Docker image, then replace that particular pod that is currently running within that particular node within the cluster and redeploy that. Instead of doing that, what you can do, we can externalize the configuration into a config map. Okay, so config maps can be accessed as a environment variable within your application. So all the application configuration need to be reading from the environment variable, which is the provided by the configuration map. Here the DB URL is MongoDB. Okay, Mongo-DB. That is basically nothing but your service name. Next come the username and password. Username and password are credentials which you don't wanted to put it in a plain text in your config map. So there is for storing secret like SSL keys or other keys, right? Or any kind of API access token, etc. We can use the secret. So secret basically stores the plain text in a base 64 encoding. And then that can be used as an environment variable from your API application. Now, out here, the API application is a stateless service. It doesn't contain any state, right? If you remove one pod and you replace it with another pod, your API application server will behave the same way. But that is not the true for your MongoDB server. Where in the MongoDB server, you have to have the data that is stored, right? So if your one server is down, then the another one pod is down, the another pod would come up. But they need to be accessing the previous data that is stored into a particular physical path. So for that we use volumes. Volumes are basically mapped to the node in which our cluster is running, their physical path. That means it's a local storage, or it can be a cloud storage like S3 or some other storage, NTFS, or any kind of other physical persistent store that can be mapped. Okay. So then if your MongoDB server is down, one pod is down, another pod will come up, it will pick up that same volume map, and all the data it can serve from its to the application API. Then now, if I need to manage the deployment, then I have another component, another abstraction on top of services is the deployment. What is basically abstraction over a pod. It basically says or define what is a pod is. It may define what is the resource that is required, okay, in terms of CPU and in terms of memory need, right? Similarly, now in our these services, deployment can be two type, just like our services. They can be either stateful or they can be stateless. Examples are any kind of database or in app server or Elasticsearch, right? So now our deployment can span across multiple nodes within our clusters. Okay, and then what you can do, you can deploy and then you can mention how many pods are required, number of pod or replicas. Then it will see in the nodes what are the amount of resources are available in terms of CPU and memory, and disk space accordingly it can deploy across that. So when you're going to be interacting with a particular application component, you basically deploy them as a deployment, and you can then modify the number of pods or the resource constraint, etc., by modifying the deployment that is there. Unless so far any question on this? Okay. Fine. Now let's look into Kubernetes architecture. Kubernetes architecture is basically consisting of two types of node. One is known as a master node and others are known as a worker node. So far, whatever we mentioned previously as a node are basically worker nodes. And now, if you can see this picture, what is the master node does? It basically controls the cluster and it is responsible for scheduling the pods. It can then responsible for recognizing a new node being added or removed from the clusters, then orchestrate and deploy that or schedule those particular pod to be deployed into different nodes as per the services currently are there. And if you see in the master node, there are different kind of sub-component are there. So the control plane here has a master node and these are basically worker node. So on the worker node side, you need to have three things. One is your container runtime, that is the Docker need to be installed. Second, you require kubelet. Kubelet is basically an interface or component through which the master node can communicate with this particular node. So they basically an agent to which the master node can communicate. Then proxy is basically take care of communication within the node or across the node. That is the request that is originating from there. Now in the master node, you have different component. One is a scheduler. One first is the API gateway, API server. Then you have like a controller manager, or you can have like a cloud controller manager, or you can have etcd xt, that is the storing the state of the persistency state of the cluster. So as I mentioned, the worker node, the multiple ports per node. Container runtime is Docker, and also it has like kubelet, which is interact with the Docker and worker node. It start the pod, allocated resources, etc. Proxy is a network proxy. It's forward the request inside and external to the cluster. So that is what is the worker node consists of. A master node is consist of, what is the master node does? It schedule the pods. It monitors the pods. If the pods are become unhealthy, so if unhealthy pod, that means it's not getting any health response, it removes that particular pod and replace the pod with another pod. That means reschedule the pod or restart that particular pod. Reschedule happens when there is a demand is more CPU demand or more requests are there. It creates a new pod within the cluster nodes, worker nodes. And if a pod has been crashed, so it can restart the pod within that particular node or a different node, depending on where the node related resources are available. Then the worker node it manages to worker node when they join the cluster, and it also store the cluster states and the node states. Okay. Now the major thing is that how can we interact with the Kubernetes cluster? If we need to interact with the Kubernetes cluster, in a cluster there are most probably minimum two master nodes. One is primary, another is a backup secondary. Okay, and they have like an API server. API server is a gateway. It's basically a gatekeeper. What it does, you can interact with the API gateway whenever you need to modify the state of that particular controller, particular cluster. For example, you wanted to deploy a new service, you wanted to update the number of pods with that particular service, etc. Now it also authenticates like which kind of client can interact with it, and it takes the update query means modification to the state of the cluster by adding, removing services, replica set, etc. Basically, mostly we deal with the deployment. Now, this API gateway can be accessed by your UI services or UI tool. It may be accessed by kubectl CLI. It can be accessed by the REST API, which can be also be implemented using Python. Now, scheduler. What is the scheduler does? It schedule the pod to the worker node. When it's scheduled, how is scheduled? It's scheduled intelligently by checking how many resources are there. Say there is pod A and pod B. One has like a 30% resources are available, other is a 60% resources are available, or maybe 70%. So then it goes to the pod B for allocating that particular resources. Next comes the your controller manager. So what it does is restart the pod, reschedule crash pod, or restore the cluster state. So for example, I say I require two pods for this particular service. Now one pod has been down. So now the desired state is number of pod, but we now have only one pod. So it's going to be create a new pod by keeping the state as desired by the user. It basically ensures that the user desired state are achieved as per their specification. Now, XT is basically key value pair of percentage is stored. It stores which other nodes are part of the cluster, how healthy are these nodes are, which pods are active, which pods are basically healthy, which pods are not responding for health informed. So in case that part maybe need to be removed and rescheduled to a different. Okay. Now in our local, how we can execute Kubernetes. So in our Docker desktop, we'll find there is like a Kubernetes option is there, and that Kubernetes option you have to enable. When you enable that, then you can use kubectl, that is the CLI tool that interacts with the API server of the master node. So in our case, what happened? We have only one physical laptop. So we have only one physical or virtual node, right? Mostly our case is a virtual node. So virtual node has, in this case, had both master node as well as the worker node together in the same virtual machine, right? But in production, they will be like different. So in locally, if you have like a Mac or something, if you wanted to execute, then you can use Brew to install both of these. You can update the Brew, and then you can update Minikube, and then you can update the CLI tool using kubelet. Both can be installed using Brew, that is for Mac, and you can also use the other installation that comes for your Windows. Okay, so what is Minikube allow us? Minikube allow us to create a single node Kubernetes cluster with the master node as well as the client node both side, and they basically create a single node cluster. Okay, now let's see some of the basic command of kubectl. So basically what we have is we have deployment, right? So deployment is the unit that we're going to be interacting with. We are not going to be interacting with volumes, or we can interact with services. We can create, delete, update that, but it's desirable that you interact with deployment. So if you wanted to create a new deployment that may be consisting of one or more services, then you can set up kubectl create deployment and the deployment name. And here you can also mention the image name. Okay. Then you have kubectl edit deployment. That is if you wanted to update the existing deployment. And then you have kubectl delete deployment. That means if you want to shut down any kind of deployment with services that's there. And then how can we monitor the server state? What is the server state consist of? One or more deployment. So we can say kubectl get deployment and the deployment name. So you can get a specific deployment detail. Then you can also look into what is the worker nodes are there. Okay. And then you can check what are the services are there. And also, if you have enabled replication of that particular node, then there is like a replica set that has been created in case of if you are using. Right. Now, another important thing or local debugging important are the debugging the pod. So how can we do that? We can log to the console file kubectl log, and then we can mention the port name. So, for example, if you want to see the what is the error or the log on the configuration, right? So, till now, if you need to access that, what you need to do is kubectl logs. You get the particular application log or database log, right? And if you wanted to interact and execute multiple bash command, lookup different file, or change the configuration manually, wanted to search something, then we can do kubectl to open up the interactive command kubectl ext interactive mode prod name and the service is binbash. Okay. Then you have configuration file. Now all of this creating deployment or creating services are generally represented by a configuration file. Okay. Now, how we can do that? So we have to create a configuration file. What is a configuration file? Is mostly a YAML file. YAML file contain every definition about the deployment, and then you have two commands. One is if you wanted to deploy the particular deployment, you can choose kubectl deploy, or you can choose to remove that, then kubectl delete. So let's see how we can enable in our Rancher desktop. So Rancher desktop, we have the Kubernetes configuration. Here by default, we choose Docker API using Docker CLI. Okay. And then you have enable the Kubernetes. So you have to check this. When you check this particular server and this particular port, the Kubernetes API get started. So we can open up any command prompt. We can check the state of our node, right? So what are you going to do? You cl get node. So this is my laptop ID. This is in a ready state. It has master as well as it has control plane. So that means it has hosting in the both the worker as well as the master node. It has been started, and the version of that particular Kubernetes is 1.22.7. That version currently is working. Now we can also check kubectl version. So this is like a version that is there 1.22.7. There are two versions. Client version is actually little bit updated. It is 1.23.4, and server version, that is kind of like outdated little bit, one minor version back, that is 1.22.7. So with kubectl version you can get both the client version as well as the server version that is there. Now what are the other commands that you can execute? Let's see basic kubectl commands. So these are the basically mini steps for starting the kubectl in Mac using minikube. Now next thing is the kubectl get nodes that we just does, that node we are getting. Now if you wanted to get the next thing, that is the pod, that is the another component, the lowest most component. There is no pods currently is available. Similarly, kubectl services, there is nothing. This one services that is by default running, that is the Kubernetes service. Okay. Now, for example, I wanted to create a deployment. So here the Nginx deployment will be there with the image Nginx. It is the public Docker image that will be deployed. kubectl get deployment Nginx dep image Nginx. Yes. It says the deployment has started. If I see the services, there is only a single service. If I see the pod, there is one pod that is getting started. Similarly, now I can check deployment. So it's going to take some time to get it started. So as I deploy, what happened? The pod get deployed. The deployment is created. Okay. And then check. Okay, see, it is not yet ready state. So it will take some time. So container is currently there, is creating. What else we can check from there? We can get the services, we can get the deployment. Then we can also check replica set. So now here the replica set is showing that by default we haven't given any kind of replication count from the command line. So there currently by default one container is there, that is in the desired state is one, current state is one, and out of that one is also ready. Okay. Now if I see the pods, now the pods has given a particular address, deployment has given an address, after that the pod has also given a name. Now the pod is up. Now I can see services. Services is still the Kubernetes is the only service. Now here we have that particular deployment is there. Now there is another option to update the deployment is by calling edit method. When you click the edit method, what it does is it open up a configuration file that you can edit and save. We're going to come back to the configuration file, but as you edit, you can obviously update the configuration file for the Kubernetes, and that's the condition. Now the edit is got cancelled. The pod is just running. There is no change. Similarly, deployment also remain the same. If we make any changes, then it will do the changes. Now kubectl logs. What is our pod name? This is a pod name. So let's copy this. You are getting a log from that particular server. That is from Nginx or web server. That you got it. Now, if we need to go inside the log, inside the container is not here. This is a pod that we interact with. Now, here what you can do, PYG interactive terminal, then that is the pod name, and then you can say in. Now we are within the particular pod. Now similarly, we can also deploy the another one, that's a MongoDB. It is again deploy. Now as it deploying the next one, you can go and we can see that it is got deployed. So now we can see there are two pods also been there. Here we can also copy the pod name. MongoDB server detail that is there that we currently can see. Okay. Now how we can now do anything in terms of deleting the deployment. Create it and also delete. It is deleted. Now if you can get deployment, then we only see this. Now similarly, we can use in the next step. Now if we go into the deployment, there's nothing. Similarly, we go inside the pod, there is no resources. Now, if you wanted to use the configuration file, so here is the basic deployment configuration file is there. Okay. So first is saying what it is. It is a deployment. Next come the metadata. What it says is the name is this one and the label app is equal to this one. Then come the spec or speculation where the replicas are 1, 2, 3, etc. Selectors are there, which is basically selecting based on matches the label. And then templates also has a metadata label. The spec has a container blueprint, which says which version of Nginx we need to run. what is the container name, what is the container port, that is been corrected. If I want, instead of I typing saying what is the image, we can put all the configuration out here and can do kubectl, and then we can apply the deployment. Now the deployment is being created. So you can see now the new pod is running. The deployment is also running. Similarly, if you wanted to delete, then instead of saying deployment and all those things, we are passing the file and the configuration file. You can now see there's no deployment, there's no node. Both have been applied as well as been deleted. Now how we can edit this? Okay. So you apply this, you check that, and you can also delete that. Okay. Now understanding the configuration file. So what is the configuration file is consist of? It's a YAML based file. We mostly know what is YAML is. Okay. Now it has a metadata. That's the first thing after the kind tag. It has a label which is connect to deployment to the pods, and then connect services to deployment. Then there is like a spec or specification which has a selector which basically matches label, and there is a template which is blueprint for the pod that basically state what is the pod, port should be open, etc. And it has also its own metadata and specification. Next is state. Where does state come from? State are basically come by kubectl get descriptor or then deployment name, and then you output that content as a YAML file, and you basically store into a file. And now we have an example of that. What is basically third part is the status. How the status is managed or who creates the status? The status is basically managed by the Kubernetes. Here is the status. Here the status says how many count of replicas are there. Then it says what is the last transaction time, what is the last update type, what is the message, what is the reason of that message, whether the status is true and the type is available or progressive. So here at that particular time, that particular Nginx deployment when has been done. So one particular node is deployed, another node is currently and the updated replicas are what? Read replicas how many? Observation difference. All these things are managed by statuses are managed by your Kubernetes cluster. Okay. Now here we're going to find there are two kind of classes are there. One is deployment, one is service. Now what is deployment? Okay. Deployment has metadata. Like metadata, there is a spec, there is a metadata, two parts to it. Okay. Now, how many replicas you require? You require actually one replica. Next comes the selector. What is the selector is saying? That I'm going to match the label. Here on the metadata, I can see there is, this one is actually deployment. The main labels are basically name and key. Now, when basically they say application engineers, okay, and here the specification says the application also match to engineers. So that particular label match. So it's bound that particular specification with this. Now comes the template. What is the template does? Template has its own metadata, again the same label, and the container. Specification says what is the container. So what is the container will be? This will be Nginx container, and this is the particular version of Nginx that they will be used. And then what is the container port? Container port will be 80. Okay. That's the configuration we understood. Now let us look into the services part. Services part, it's a service. It has a metadata. Fine. It has a selector, which app metadata. So here the service is linked with the deployment. Now the ports are being mapped. So what is the external port out here? Is the 80 is the external port. What is the target port? Internal port is 80, 80. And the request will be forwarded to 80 to 80, 80. The protocol that is the TCP. Okay. Okay. So let's see our project that we have done, right? And that particular project also we have so let's just show it from Bitbucket. Okay. There are different three, four different services are there. Now under DevOps, what we have is we have different Kubernetes files are mentioned. So here we can see there are three services which have been mentioned. One is image service, one is taxonomy service, one is text service, and there is a like cluster.yml. Okay. So let's understand what is the cluster.yml file is about. So this is an EKS cluster configuration for Fargate profile. Okay. EKS ctl.io, they're choosing a particular version. Kind is cluster config. Now, as you know, there will be a metadata, then there will be something like other details. So here in the metadata, what are the details are there? It's basically key value pair. So one name is that what is the name of the cluster, which region this is currently in, what is the version. Then the tags are defined separately. Tag 1 is Dave, created by a person name. Then you have approved by person name, whichever the last change, and the project name. Now, out here, there are ECS specific details are mentioned. Okay, that's not Kubernetes specific, but it is highly modified configuration file that manages the cluster creation. Okay, so here we have some metadata that we have already gone through. Now come the metadata notebook. So it says which image size we're going to take. This image size we're going to take as EC2 image size. And what's the capacity we're going to take? We're going to take the capacity as 1. And then the max size is 1. Okay. And autoscaler is by default true. And minimum and maximum sizes different, and diesel capability is there. Here we have YDC specific autoscaler. So that will be done. Now here we have to use a particular CloudWatch cluster logging under CloudWatch, and the event type are different kind of event type they are logging in. So they are basically logging the controller manager, API, audit, authentication, all those events that are happen in the master nodes. Now private cluster is enable small autoscaler for client autoscaling and CloudWatch log. These are the different there. VPC they have mentioned, subnet they have mentioned, private and public subnet that is there. That is specifically for EK space. Now, if you go into one of the services, now one of the services what happening is there is a one component is a configuration map. So let's see how the configuration map has been defined. So what is a configuration map? It's basically an externalized configuration. So here what happened is it's a config map, and it has a metadata, it has a name, and it has a namespace. Now this map has a different data that is there. Here we should have here we have used the some part of detail that is like the host and port, which are bound to change between the environment variable, and the rest of the normal strings we have mentioned. Next comes the secret. Now what is the secret that you know? It is basically base 64 values. So what is here? Here we can see the elastic cache username, password, client ID, and GAN type. And the GAN type is not modified, but anyhow one needs storage in base 64. And the client, the type. Okay. All of these things are secret. We can, they have put into a single file, but we can, broken down into different files, one for secret, one for cluster, one for deployment, one for service. Next was comes is the deployment. So deployment is basically has a label. Now it has like 2 replica set, that means 2 pods will be created, and maximum search ruling update is the deployment strategy. Maximum search is 1, so 1 by 1 the pods will be replaced in case of the deployment happen or the rescheduling of the pod is required. Now selector is basically matching label. It just uses the same label at the top and this will used below. Now comes the template, which has nothing but metadata, label, and app app related label, nothing more. Now out here under template there is like a spec, and in the spec you have volumes are related to AMD and ARM, right? And then they are using Kubernetes IO architecture, match expression, so node affinity. So what is the node affinity means? This node, okay? So this node when being deployed, it will be deployed with a node where the nodes particularly have the specific architecture for their machine, right? So here they're saying that required desire scheduling ignored during execution. Node selection term, when this particular conditions are fulfilled, then only that particular node, the pod will be deployed. Next comes the container related detail. So container related detail, what is we are pushing it? What is the requested? We are hoping to get this many CPU and this many memory to execute. And what is the hard limit they have set? This many hard limit they have set. Docker image URL they have mentioned, and the container name they have mentioned. Now environment from, so we have two kind of environment. One is secret, one is config map. Whatever config maps names and secret ref, those refs are basically going to be set up as the environment from where our FastAPI application will be able to read the values. Now comes the HTTP port. So for HTTP port, we are wanted to run on this port HTTP at 8000. Okay, readiness port that they have mentioned. Readiness port, not port. So how often this particular node will be checked for his readiness? If it's not able to run within 10 minutes or so, 10 seconds or something, or 5 seconds or something, then that particular node is bound to be unhealthy. So here the node is going to be initiated. Initial delay is about like 5 seconds, and periodic seconds are 30 seconds. Aliveness, so readiness means when the server is up and running. Liveness means when the server is running, and now we're going to check after certain interval, see how it is being responding, right? So it will poke in particular HTTP endpoint, and it will have like initial delay of 120 seconds when the server first time is continuous first time is up, and then the after every periodic 30 seconds it will poke it. Next comes the services. So in the services you have the metadata, and you have like any kind of values you can put that. One thing you put that. What is the label we're going to be mapping this to? And now comes the node port or the spec, and it is being which port that will be mapped to. So this is the target port, and this is the port that is being mapped. Now also the horizontal autoscaler has been introduced, right? So that means how the scalability will take care of it. Now here horizontal autoscaler or the HPA, the name has been given and that certain namespace has been given. Minimum replica is mentioned as 2, maximum replica as 10. Scalable target attribute, so it is like a deployment. And when the CPU utilization going to be reached 50%, then it will bump up, right? It will create new pods and then it will be deploying there. Okay. then we can use this file and we can apply, and our cluster, it will be getting deployed. So that's more or less about the configuration and how we can use them. Any questions you guys have? So you can, before pushing that particular Kubernetes cluster, you can check it out in your local. Okay. Okay. So let me pause the recording for now.